Hello, can you hear me?
Yes, ma'am.
Okay. So we did discuss bootstrap using R in the earlier lecture. So now we will discuss, today we will try to do cross validation, leave one out cross validation, k-fold cross validation, just the training set, testing set business, all those things using R. Okay. So let me share my screen. Okay, so can you see my screen?
Yes, ma'am.
Okay. So again we will start with some random data, but today we will start with the supervised learning setup. So instead of having yesterday when we were trying bootstrap, we used data from exponential distribution. So today we will have some data from regression type of setup so that we can try to predict that y. Okay, so let me first take some x I will take uniformly, so let me define some n, let's say 100. X I will take between uniform 0 to 10, let's say. Okay, and now y I have to construct, so I'll construct y as, say, let me introduce some beta naught and beta 1. So beta naught is suppose 2, beta 1 is suppose 3, and beta 2 is suppose minus 1. Okay, and I'll introduce y as beta naught plus beta 1 into x plus, say, beta 2 into log x. I just want to have some complicated function of x, that's all, plus error, of course. So error I'll get from r norm n. Let me take standard normal so I don't have to specify. Okay, my x is supposed to be capital. Okay, so let me see plot of xy. Okay, interesting, this is still pretty linear. And now, so what we are going to do, we are trying to find relationship between x and y via different methods, and we have to compare different cross validation methods. Okay, so first we will go for train test approach, and in each method what we are going to do, we are going to have multiple trials. Okay, so we are kind of going to assume that the experiment is being repeated by, say, 50 students, and then we will record training error, test error for each student, and then we'll try to see if the test error follows u-shaped pattern, etc. And I don't know whether we can do that today, but we'll try. And we'll also try to see how the variance of test error changes with the cross validation method. Means how much is the variance of test error for simple training test approach, how much is the variance of test error for fivefold cross validation, tenfold cross validation, and then maybe for leave one out cross validation, that is jackknife. Is it clear what I am trying to do?
Yes, ma'am.
Okay, so we are going to store training error as well as test error. So let me have train error as one vector and test error as another vector. These two I am creating blank vectors. Okay, now as I said, I am going to repeat each of these exercise 50 times, assuming that 50 different students are doing this. Okay, we want to see the variances. So n is equal to, let's say, 50, not n, I already have n, so let me say ns equal to 50. So first let me do train test approach. So train test. So we will divide data into two parts, 50-50% every time, and one part we will consider as train data, another part we will consider as test data, and we'll compute mean value of the mean squared error for training data as well as for test data. Okay, so for I in 1 to NS, just a minute. Okay, so for I in 1 to NS, what is the first thing I have to do? I have to divide my data into two parts. Okay, I have to randomly divide my data into two parts. So how do I do that? Random division into two parts. I have to name one part as train and I have to name another part as test or validation set. You can call it validation set also, but yes, how do I do the random division?
Ma'am, we can randomly select the select the row numbers, and then we can just extract those rows actually that the sample has from that the sample has been drawn.
Okay, so let me first combine x and y so that this is my data set. Okay, xy. So now I have to randomly sample some row numbers from 1 to n, and how many? N by 2. Okay, so let me take k as not k we are going to use for k fold. So let me take m as floor of n by 2. You know the commands floor and ceiling, right, everyone?
Yes, ma'am.
So right now my n is 100, so it doesn't matter, but I want to write a general code, so I am writing floor of n by 2. So now I am going to select the rows. So for selecting those rows, what do I need? I need some sample. So sample of size m from 1 to n, replace equal to false. I think by default it is false. Is my sequence correct, or do I need to give 1:n first? Good, nobody knows, but it didn't give errors. Okay, interesting. There is some issue. N is 100, but still it gave me a sample of size 1. So what is the problem? Okay, so you need to specify the set from which you want to sample first, and then you specify the sample size. Okay, and to avoid these types of errors, what you can do is you can simply use the arguments. Correct, I mean you can name the arguments. Okay, so where was I? Yeah, so now I have to take those rows in the training sample and remaining rows in the validation set. So minus s. Is it okay? This rows corresponding to the selected numbers, that is 71, 18, 11, etc. they are in the training sample, and all the rows other than those are in the validation set. Okay so far?
Yes, ma'am.
Okay. So now for the time being we will try to fit only simple linear regression model, because see, looking at the graph I would be tempted to say that this is simple linear regression. I won't really worry about this log x business, because in reality you would never know the exact relationship between y and x. In reality your analysis starts from this d. You will already have d with you. You don't know where that d has come from, whether it has come from a linear regression model, whether it has come from polynomial regression model. You don't know anything. Okay, so you will just have d and then your analysis starts. Okay, the earlier part was just to simulate the data. So simulation part you have to forget once you have the data. Okay, so we are not going to use any information from here. Okay, so looking at the graph, I am tempted to say that this is a linear regression model perhaps. So I will try to model the given data using linear regression. Okay, so how would I do that? Now I have to model, means I have to fit the model only to the training part. Validation part will be used just for getting the prediction error. Okay, the model fitting, estimation of beta naught, beta 1, etc. is to be done only on the training part. So I will have LM train 2 tilde train 1. Is it okay? Is it okay?
Yes, ma'am.
Yes, ma'am.
Okay, I did not run this part. Okay, so I got some coefficients. So this is my intercept, this is my slope. So I have to first compute training error. Can I get training error directly from some regression, from some part in the regression output?
Yes, ma'am. From L and then the dollar sign, it would give you a dropout only for residuals.
So these are just residuals, but I want now mean squared error. So what should I do? L dollar residuals,
Ma'am, we can store this summary of L as another vector and then get the MSE directly.
MSE also, but now that I have residuals, I can do this also, correct?
Yes, ma'am.
So mean of these, right? So this is my training error for ith simulation. Okay, so let me run and see what is the value. Okay, so here this is the value. Similarly, I have to compute. Is everyone clear how the training error has been calculated?
Yes, ma'am.
Okay, so how do I get the test error now?
Ma'am, I think it is exactly not the mean of it. It must be
N
divided by the
minus
degrees of it.
n minus 1.
Yes.
Yeah, n minus 1, but for our purpose it doesn't make much difference, so I'm going with n.
Okay.
You're right, ideally it has to be n minus 1 for unbiasedness and all, but right now I'm not much worried about the estimations. I just want some estimate, and anyway for large n it is more or less the same. Okay, yes. What about test error? How do I get the test error?
Ma'am, we'll predict first y from the intercept and coefficient. We'll set up a model and then predict y for the test values that we have set.
Okay, so how do I do that?
Um, uh, we can go for y pred equals to the intercept, that is 2.025.
I'm not going to type 2.025.
Okay.
Too lazy to do that.
Uh,
Because every time I change my model, my intercept is going to change, right?
yes, ma'am. Then L
Repeat this
square
50 times.
L dollar coefficient square bracket 1
Hmm.
plus same L dollar coefficient square bracket 2, and this will be multiplied with our test data set.
So valid 1, correct?
Yes, ma'am.
X part of the test data. Okay. Any other way of getting the same thing?
Ma'am, the residuals we can anyway calculate.
Oh. Stop. Trace residuals will not use test data. I want to use test data. Trace residuals will be calculated based on the data that has been already used in the sample. Just that it will be leave one out cross validation. But right now I am going for a train test approach. I am not going for leave one out approach. Are you getting what I am trying to say?
Yes, ma'am. Yes, ma'am. I got it.
So new test data has to be used somewhere. The data that we have kept aside, this validation set. Any other way of getting fitted values in a regression model? for prediction values. Ideally, I should say not fitted values because I want to.
Ma'am, there is one function that is predict.
Correct.
So yes, ma'am.
So there is a function called predict.
Yes.
So I don't know whether you people have used it, and it works for many models. So uh, linear regression is one. It works for many models. It takes that object. So here it will take this L as the input. Object is,
And the data frame.
then you give the data, and then it will give predictions. Okay, see, predict.glm, predict.lm, predict.loess, predict.nls. NLS is I think non-linear regression type of thing. Predict polynomial regression, then principal component, and many things. Okay, even for time series, AR, ARIMA, Holt Winters, structural time series, etc. Okay, so homework is explore the predict command, try to use it. Okay, it's not exactly very straightforward. Slight caution needs to be taken, so homework is do that. Okay, so I have I predicted now. So test error for this particular student would be mean of, now I want to calculate the residuals here. So what is the formula for residuals? Y minus y hat or y hat minus y?
Anyway, anything.
Anyway, we are taking square, so it doesn't really matter. So y pred, and actual y is where? Actual y for these observations is where?
Valid comma 2, the second column.
Valid comma 2, correct? So this minus y pred whole square. So this would be my test error. So let me run this part. Okay, so this is test error. You can see test error is larger than the training error. Can you see this?
Yes, ma'am.
And now I have to repeat this exercise 50 times. Why? Because I want to see if different people do this exercise, how much variation is there in their values. Okay, so I'll repeat. So that's why I've written this I loop. I have not run that so far. So all the inside things would run ns times. Ns is 50, and the train errors would get stored in the vector called train errors. Test errors would get stored in the vector called test errors. I'm not storing the coefficients as of now because I'm not interested in them. Okay, so let me run this part. Okay, I got something, so let me plot train errors. So training errors are roughly between say 0.8 to 1.8. Okay, and what about test errors? Test errors are slightly higher. Can you see? Let me plot. What is this telling me? Is this expected pattern? Whatever I'm doing, is it expected pattern or unexpected pattern? Any guesses are fine. I mean, you don't have to be perfect.
Yeah, maybe, yeah, yes, it is expected.
Okay, bye.
Since whenever our test error will higher, your train, or in the reverse, whenever our training error will higher, the test error will be less.
Why?
Because in that case, our model will be more correct.
Ma'am, I think there is one. Ma'am, whenever the tester is actually lower, whenever the train error is lower, the test error is higher because there is one problem of overfitting of the model is occurring. So in that case, so in that case, when it is overfitting, when the case of overfitting is occurring, the model is actually model is trying to recognize the train data set so well, such that whenever it is actually facing the new data points, it is creating or it is facing problems in front of that. So if the so if so if the train set and thus the train error whenever it is increasing and thus the test error is also increasing, that means it is not increasing significantly, but it is also performing well in front of the data set tree. So here is
So
that.
see, yeah, what Kushal is saying is correct. When the train error is too low, perhaps the model is overfitting the data and hence the predictions turn out to be worse. Okay. And what is going to be the intercept? So the slope is negative, it's obvious from the graph. Intercept is positive or negative for this graph? For this graph, intercept is positive or negative?
Positive.
Positive. Okay. Now, can you interpret that part? Why would intercept be positive?
Whenever our training error will be zero, it will predict the uh, your data in the training correctly, but in that case, our testing data will not be predicted that much correct.
So it is same interpretation that you are telling which we used for negative slope. Any other slightly, I mean,
Ma'am, ma'am, actually the thing is that the test error is nothing but the mean square error, whatever we are calculating. So it cannot be greater than, it cannot be less than 0. So in that case, if it is, if the train error is anyhow equals to 0, then it is nothing but the intercept value which we will be getting, and it cannot be negative since the test error, that is nothing but the mean square error. So it cannot be negative. So it will
correct.
be
Test error
automatically
is a
positive.
mean squared error, so it cannot be negative. What is intercept? Intercept is that value of y which you obtain by putting x equal to 0. Correct. So here x equal to 0 means training error equal to 0. Training error, if training error is 0, test error could not still be negative, because anyway your test error could never be negative. You are taking mean of squares. And another thing is, your test error is generally, in most of the cases, your test error is going to be higher than the training error. Okay. So that way also, test error is going to be something plus the training error. Okay. Okay. So now we will compute variance of both. Variance of train error is this much. Similarly, let me compute variance of test error. Okay, it is 0.07. Okay, so this is for the which approach? Validation set approach. Okay, let me now try fivefold cross validation. Okay, fivefold cross validation. So all these things I have to do, but with now fivefold cross validation. So we can copy and edit some of the commands instead of and we are going to use the same data set, just that instead of using train test approach, we will go for validation set approach. Oh, sorry, I want to paste here. Okay, so now I want fivefold validation. So in fivefold cross validation, how do I construct my training set and test set? Let me write a code for k fold and then we'll run the same code by changing k. So right now k equal to 5. So how do I construct training set and test set?
Here we will be actually extracting uh, k sets of observations each time without replacement.
Correct. So how do I code that? So I can now, instead of choosing the training set, I can do n by k. So for example, for k equal to 5, my n by k is going to be 20. Correct. So now I have to choose 20 observations as test set and remaining 80 are going to be in my training set. Are you getting what I am trying to say? But the thing is, I need to know, I need to have sets of 20, 20, 20. Why? Because every time I am going to keep one of those sets aside as my test set. So I cannot simply have 80-20 division. Okay. So I have to have 5 samples, each of size m. Okay. I have to have 5 samples, each of size m from 1 to n, and I have to make sure that there is no replacement. So how do I code it in an easy way? Is there any easy way to do the coding? I don't want to write, suppose, the sample command 5 times. Of course I could do that, but then I have to make sure that there are no repetitions and all, and I don't want to do that. I'm too lazy to do that. So is there any easier way to do this division? Yes.
Ma'am, can't we frame a list?
Okay, and in that
Uh,
list, how do
the,
I assign elements?
yes.
That
We
is
will
my
be
question.
assigning the data sets, five
Yeah,
different
but
data
how
sets.
do I construct those 5 data sets? That is my question. How do I construct those 5 separate data sets? That is my question. How to store them is list. List is an answer for how to store them. But I want
Yes, ma'am.
the question, how do you construct them?
Uh,
Can we
Others should
do
also talk. Kushal and Pushkar are hopefully not the only student present in the class.
hello madam?
Yes?
Can we do like draw sample of size n and then divide that in 5 parts
Okay. Draw a sample of size n with replacement or without replacement.
without replacement?
Correct. So this is perhaps one of the efficient ways of doing what we are trying to do. Instead of drawing 5 samples, what I can do is, see, what I want is, I want some arbitrary elements. So I want, if I order the existing n observations randomly, and then I say that first 20 from them I'm going to pick as first set, next 20 from them I'm going to pick as next set, and so on, then it should work. Is everyone getting what is happening over here?
yes, ma'am.
Who said yes?
Me, Kushal.
No, I want someone else to speak. At least this yes no business, someone else should speak. Maybe Kushal and Pushkar are getting, but what about others? Are you getting what is happening here?
Yes, ma'am.
I was expecting Prathamesh to reply, but what about other people? Those who don't talk? Yes? Are you getting this idea?
Yes, ma'am.
Okay, so we will just randomly arrange the n objects, the n observations, And then we can say first 20 will form one group, next 20 will form another group, next 20 will form another group, and that's it. I don't need sample command now 5 times. I just need sample command once for rearranging. Okay so far?
Yes, ma'am.
See, I could give this R thing as homework, okay, but then I know that most of you would simply Google the codes, and I don't want that to happen. I want you to think. That's why I'm trying to do in the class, so that at least with me you will try to think. Okay. If you feel that this is waste of your time and you could write codes on your own, please let me know after today's lecture. Next lecture next lecture onwards we will do only learning part here, and coding part I can leave to you. But I generally feel that people need that some training in thinking also, how to think in terms of coding, how to write commands efficiently. So I am doing that here. Okay, so if you feel it is not needed, please let me know. Okay, so now I'll do n sample 1 to n replace equal to false. So you can see here, see the arrangement is different. So now when I pick observation number 1 to 20, I will get 72, 11, 20, 31. Okay, so now I have to do this business of picking train and test k times, right? So for j in 1 to k, for j in 1 to k I have to do something. And then I have to do many modifications over here. Why am I spending time in pressing tab everywhere? So that my brackets I can match easily. Okay, I know RStudio matches the brackets, but still for us also it is easier to match the brackets if you know the code is properly indented. Okay, so for j in 1 to k, what I have to do, I have to construct my training set and test set. So how do I construct that? So let me say T1 is the number of observations in the training set, so that remaining observations in the test set. Or you can say T1 is number of observations in the test set, so that remaining are in the training set. So I have to pick either first 20, 21st to 40th, or 41st to 60th. I'm audible, right?
Yes, ma'am, you're audible.
Okay. Okay, so I have to pick those observations. So how do I pick that ith subset or jth subset here? J is 1 to k. So how do I pick jth subset here? J into something plus 1. Any ideas what I'm saying?
J into M.
J into M. Okay. So for j equal to 1, I'll be getting 20. You are in the right direction. You need to modify it a bit. So the ending observation has to be 20. For j equal to 1, it will be 20. For j equal to 2, it will be 2 into 20, that is 40. Now what should be the first observation in that sample? J minus 1 into M plus 1. Is it correct? Try to see. When I have j equal to 1, I would have 1 minus 1, that is 0 into m plus 1. So I will start from observation number 1 and I will go till 1 into 20. So 20. 1 to 20, correct? When I have j equal to 2, I would have 2 minus 1, that is 1 into m, so that is 20 plus 1, so 21 to 40. When I have j equal to 5, I will have 4 into m, that is 80 plus 1, 81 into, 2, 5 into 20, that is 100, 81 to 100. Is it correct?
Yes, ma'am.
So I want these to be in my validation set and remaining to be in my training set. Correct? Now I will get 5 different test errors and 5 different training errors, right? And my final estimate of training error and test error would be the means of those respective things. So I need vectors to store these smaller parts. So train part J is actually the mean training error. Then I'll have test part J is the mean test error. And finally my training error for ith sample has to be mean of these 5 training errors, each from one fold, 5-fold we said. Similarly, test error has to be mean of these test errors. Why do I need these vectors, train part and test part? Is it clear?
Yes, ma'am.
Okay, everyone? Maru, Shivani, Akash,
Yes, ma'am.
everyone with me so far? Yeah.
Yes, ma'am.
Okay. So now let me try to run this whole thing 50 times. What is happening? Why am I getting a single value? Any idea where am I going wrong? It's very
Ma'am, that NS thing must be changed.
no, NS is 50, that is correct. There's very small mistake. Yes. Can you locate?
In for loop, J is 1 to n.
Sorry? In for loop? What did you say?
There is in of I. There
No, here I have J, here I have I. So I think that's not an issue. Issue is something different. Pushkar, you should be able to spot the issue very easily. Because it came from the idea of what you told me. I mean, the issue is bad execution of that idea.
the sample is same for all.
I. So sample. No, sample is also different. Then what is the problem? Sample is different every time I'm taking a sample. Then what is the issue? Let me create blank vectors just to be safe. Train part, test part are being replaced every time. So,
Madam, where did we use that test?
sorry?
The sample. Where did we use
Correct,
the sample?
correct. That's why I told you this is a bad execution of your idea. We have not yet used that S. Sample is different. But what we have to do, what we are doing right now is from the original data itself, we are choosing first 20, next 20, etc. So every time we are getting the same sample. Correct? This S we obtained, we draw this sample, but we have not used that sample. So I have to use it. Okay? So I have to say S at T1 S at T1. Are you, I mean, others, are you getting the problem?
Yes, ma'am.
See, we draw this sample and now from this sample we have to pick first 20 observations or next 20 observations and so on. Whereas we were picking from the original sample. So every time we were getting exactly same observations. Okay. That's why I was hoping that Pushkar should be able to point out. Okay. Now we have good spread. Train error, test error. Variance of train error, variance of test error. Can you see what were the initial variances? It were 0.05 and 0.07, I think. Somewhere. Yeah, 0.05 and 0.08 we can say. And now the variances are 10 raised to minus 5 and 0.001. Can you see decrease in variance of training error and test error? Hello?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay, so let me stop here because if I now homework is you try to write for tenfold and see if you get further smaller error in tenfold. Okay, and then next is leave one out. If you can write for leave one out, that would also be good. Okay, so for today let me stop here. Any doubt so far? Are you getting whatever is happening in the class? Wow, people have started.
Yes, yes, ma'am.
Okay, and as I told you, if you feel that writing the codes here is waste of your time, you can write the codes on your own. Please let me know. Okay, we can.
No, ma'am, it is not waste of time.
You are, I mean, you are getting something from writing the code in the class, right?
Yes, ma'am.
Okay.
At least we get an idea what to write.
Okay, good. So let me stop here for today. Thank you.